All right, this is on our completing the square notes, section 4.7. Like this at the top. 4.7, completing the square. It says solve the equations by completing the square. We already did the first one. We're going to look at problem number 2 now. So on this problem, we know that if we're using completing the square method, we are going to factor, and we want our factors to be perfectly matching. Since we're looking at this equation, and I know that if I were to factor this, even if I can, it's not going to give me the same matching factors. So every time with completing the square, I don't even think about it. I always get rid of the last value because I just sort of assume they didn't give you the perfect number there. It's very rare. And you can always move it and it will always work out no matter what, even if you get rid of it. So we're going to subtract the 24 to get rid of it. It's not our perfect number. So I'm copying. And when you're doing this, you need the perfect number. So I always put a box here, a square, and I help myself remember that by telling myself I'm completing the square, and so I put a square there. So I move the 24 over. It goes over there with a 0, so it's negative 24 over there. If I'm adding something to the left side, I have to add the same exact thing on the right side. So I'm going to put a square over there to help myself remember it goes there too. So now I'm going to factor it. There is a formula for this. You can use the formula, but I choose to work it this way instead. It's much easier to remember. You don't have to think about what the formula is. And you also don't have to think about the factoring because you just know what you want the factors to look like. So I know that I don't have a value on my x squared, which is making this one easy for us to do. So I've got x and x. I know that my binomial, the number on the right, has to be half of that middle number, just every time. So half of negative 10 is negative 5.
So the square would be 25?
Yes. So when we square those negative 5s, 25 is my magic number that makes this possible. So I have to put it in both of the boxes. And on the right side, combining those right here gives me 1, which is going to help me out because I know later I'm going to square root that. So it's going to be really nice. So now, in the solving process, we have to clean this up. We have exactly matching binomials, so we're going to rewrite it as x minus 5 parentheses squared. You always, if you have matching terms like that, you want to write it like I just said. And then on the right is 1. So we've done the completing the square portion, now we're just going to solve it. And to solve a problem like this, we're going to square root both sides. When you square root, don't forget that you have a positive and a negative of your answer, and that's the crucial thing that everybody forgets. Even I forget that. So on the right, plus or minus 1, and on the left, it's just x minus 5. Because the square root and the squaring, they cancel each other out. And we're going to add 5 to both sides. So it's going to be x equals 5 plus or minus 1. And that's going to give me 2 answers. Since I don't have a radical in this, I'm actually going to solve it. So 5 plus 1 is 6, and then 5 minus 1 is 4. So I have 2 answers, 6 and 4. And again, they could put them as points, 6, 4, 4, 0, or they could write it as a solution set, like this, which is not a point, it's just a list of x values. Or they could list it like I did over here. They might also do like that and list it. So that's how we solve with completing a square if there's no coefficient on our x.